Okay, guys. So how can we figure out which COM port? I mean, we know that it's not the one that's number one, but at home, because every time you plug in a new device, it pops up with a whole new COM port. So at home, you're going to need to be able to figure out, or maybe in the future, you're going to need to be able to figure out which COM port it is. So what I want you guys to do is look at your COM ports, okay? You guys should have two different COM ports. Which ones do you guys have? So like
COM 4 and COM 1.
COM 4 and COM 1. Does anybody have something different than COM 4? Okay, cool. So what we can do is, watch this guys, if we click elsewhere, we just unplug this. Now, we took the device off, right? So it's no longer connected to that communication port, the COM port. So if we go back and look at the COM port, it's not there, right? So we know the number 4, the one that we took away, right, is the one that's attached to this. So what we're going to do is we're going to plug these back in. Then we're going to go back and we're going to select our serial port, our COM port again. Okay? And which one are we going to select?
COM 4.
COM 4, because we know it's 4, because 4 went away. All right. So we've got that selected. We've got a question here. Yes, Alyssa.
I don't have a question.
Yeah, okay.
When I pulled mine back up, it went red, yellow, and then the blue light circle.
So the red and yellow are the RX and TX. So that means that we plugged it in and information is being passed back and forth from this computer to the other computer. From this little robot brain to the other robot brain. Okay? Watch, I want you guys, that's excellent, Alyssa. I want you guys to watch those RX and TX lights when we hit upload. So I want you to click on upload because we did those two things. We selected the board type and the serial port. So now we can upload. And we can watch, and when those lights flash, it's passing information to the robot brains.
That's cool.
And then you should see it kind of pause for a second. And then it should start blinking that blue light. That's LED 13. Because it's blinking 13. If you have a little red, if you have, see, like I got an error down here. So errors are normal.
All I did was look up there.
Oh, it is. Yeah, we're going to change how fast they shoot. I'm going to use...
Oh, I did.
It should say done uploading, and like you might get an error message down here. We're going to talk about error messages in a little bit. So if you've got an error message, red text, throw up a hand.
He just got a question or a comment.
He's got a question.
We upload the
No. Do you have an error message? Yeah, so that sounds good. So yeah, guys, I'm gonna wait until everybody's done talking.
You're all good.
You have an error message? What?
I actually have an error message, but mine was because I had two COM ports and I was
Right. So like if you select the wrong COM port, guys, you'll get an error message. Hey guys, so what's your sign for I need your attention? Is it
5, 4, 3, 2.
I would just raise hands. If he raises his hand, you'll be
yeah, if I raise my hand, guys, I want your attention, okay? Great. Okay, guys, so look at this. It says done uploading because we uploaded our code. And it tells us, you're asking about the memory. It tells us how much memory we took up out of how much is our maximum. So this is 32K of memory. And we're only using 1K, guys. So we could upload a whole bunch more code. Okay? Let's start talking about our code. So we've got our code right here. And actually, we're not going to talk about the code because I want you guys having fun, first of all. Okay? So what we're going to do, my code might look a little bit different than yours, or it might look exactly the same. Well, the first thing we're going to do is we're going to start changing variables. So you guys can always change variables. And you guys know what variables are, right?
Yes.
Nice. So variables, I'm just going to go over it really quick. Variables are containers for information, right? So just like we have different containers for physical stuff in the world, right? This is a good container for what?
Water.
Coffee, water, juice, right? What about this? What is this a good container for?
Your head.
My head, right? What happens if I try to put this stuff into this container?
It'll leak.
It'll leak, yeah. This is a bad container for liquids, right? So just like we have different physical containers for that, we have different variable types for information because there's different kinds of information. So we're gonna change an integer type variable because it can hold integers, numbers, right? But we could also have character type variables, okay? And so our character type variables can hold like exclamation points or like A or B or anything like that. But we're going to change an integer type variable. So I want you guys to go down and find delay. It's inside of loop. We're going to talk about all this stuff in a little bit. You guys are doing some hardcore programming today. It's pretty awesome. I want you guys to change these two numbers, this 1,000, because this is milliseconds, okay? These robots think so quick that we can tell them to wait for 1/1000th of a second. This guy can execute 16 million different operations per second. How do you guys think, if you guys could do that, how long do you think your homework would take? All right? Yeah. You have a question? Yeah. Yeah, I want you guys to change the numbers inside of delay. See how low you can go and still see that LED blink. And I want you guys to tell me, because these two numbers do two different things. I want you to find out what the two different things that they do are. And tell me. Even though it's the same command, where they are in the code matters, just like in Scratch, okay? So you guys can make these longer, you guys can make these bigger numbers, or smaller numbers. But I want you guys figuring out what they do, okay?
When you change it, be sure to click upload. Otherwise, it's not going to work.
So after you change this, I want you guys clicking upload. Upload is how you put the code back onto your robot brain.
You don't want crazy numbers. Not 2 billion.
Yeah. Well, you can try that, and you'll probably get an error message. You can work something like that too.
Yeah, something like that.
Okay, so if it's too long, try changing it.
So, what that did, it's just saying.
Hey guys, I've got prizes. I've got prizes for anybody who can tell me what the two different numbers do, what the difference between them are. Yeah.
The difference are like how fast or how slow.
Okay, yeah. So do you want stickers, a patch, safety glasses, or sunglasses? Sunglasses? Okay. There you go. Who can tell me what the difference between the two numbers is? Yeah. Because they do two different things. Play around with it if you're not sure.
My thing is not. One turns orange, the other turns like brown. I don't know. Digital right. It's high.
Uh-huh.
The second one. I can't remember the digital right.
Okay. So what are those two numbers when you change those two numbers? If we make like the first one a big number and the second one a small number, what are those numbers doing?
What?
That's how I handle that. Yeah. Because what about your numbers? Okay, so yeah, guys, so what was your name? Kaylin? So Kaylin's saying that the number on top, she made the number on top larger. So it's being on for a longer amount of time. And she made the number on the bottom smaller, and it's doing what for a shorter amount of time? It's turning off for a shorter amount of time. Awesome. Yeah, so one of them is for how long it's going to be on, and one of them is for how long it's going to be off. What do you want for a prize? Do you want safety glasses, a patch, stickers, or sunglasses? Sunglasses. I got a feeling of sunglasses. Uh-huh.
And mine's like it turns on, I'm waiting 7 seconds and then it turns off.
7 seconds, yeah. So 7,000 is 7 seconds. You got a question on something?
No. I changed mine to like 1,004 and mine's like 7,000.
So she changed hers to 1,004. So 4 is so small you can't see it. Yeah.
And also, the first number, if you change it to 9,5x, it would wait 9 seconds and then it would.
9 seconds, totally. I agree. So that's so like 9,000 is 1 second. So guys, what's the smallest we can make both of those numbers? If we make both of those numbers the same number, what's the smallest we can make those numbers and still see it blink? I want you guys to figure that out, not guess. You good? Oh, not 5 in the back there. I want you guys to change it. Change it. You can figure it out. You can figure it out. What's the smallest you can make this number?
Oh, I figured it out.
Because 5, you won't be able to see it blink at all. I guarantee it. You have the answer?
-1 trillion.
1? Oh, you guys are guessing. I want you guys uploading the code.
I can't.
You can see a blink when they're both at 9? Let's see. No, we want to change them both to the same number. There, guys, change both of them to the same number. So change both of these to the same number, and we want to know what's the lowest that we can make this number and still see it blink. Yeah. 2? You can't see it blink at 2. You're kidding.
Yes.
0? No, you won't be able to see it blink at 0.
I know 7.
You can see it blink at 7?
That's blinking fast. I can definitely see that.
You can see that? I can't see that. 10? Okay, guys, she's got 10. She's got 10. You can just barely see, and it depends on how young you are and how well you take care of your body and what maybe you ate for in the morning. So she's got 10. She can see that. I can believe that she can see that. Most adults can see about 12. Okay? But this is turning on and off so quickly. This is turning on and off so quickly that any lower and you wouldn't be able to see a blink. But guys, look at this. What happens when I do this? Can you guys see it blink easier?
Yes.
When I start moving it? No?
Yes, I can.
It's called persistence of vision. So this is starting to show you how quickly these robots. You want sunglasses, huh? This is showing you how quickly these robots are moving. And also it's showing you that we can connect this stuff to biology. You guys can learn stuff about biology through this technology. It's not 10? You can't. She says she can see it blink. I believe her. Well, watch, if you move this, you start moving it, and you start to see it blink. Try 12. Try 12. Try 12 for both of those, and see if you can see those blink. Almost everybody can see 15. And it really does, it depends on like what you ate that morning. As well as like how old you are, honestly.
Yeah, we're learning it.
I get kids who are like, oh, I can see 8. And I'm not sure if I should believe them or not. But if you move it or you look at it in this corner of your eye, because the way human beings develop, it's more important that we be able to see movement than constant. So yeah, it's cool. You can connect this to geometry, algebra, calculus, biology, all of the sciences, all the engineering. It just takes a little bit of creativity. I wish that's the plan.
My favorite room are made up
That's right. We try to make it as effective as possible.
Okay, so
It's more public versus freedom of information. It's true equalizer. It's a great step.
No.
Okay, guys. So next challenge. We got some safety glasses left over and some patches left over. I want to see. Okay, we're going to see who can make a heartbeat. A heartbeat, so long, short. And the way we're going to do that, guys, is we're going to copy these 4 lines of code. So make sure you get in between, and we're going to talk about the curly brackets and stuff for a little bit. So these curly brackets, we got to copy the stuff that's in between there. So we highlight it, we copy it, and then we got to paste it, but we need to paste it in between the curly brackets. Curly brackets are like hamburger buns. You always need one at the beginning and one at the end. You can't pick up a hamburger without 2 hamburger buns, right? So we always need one. You can. It gets really, really messy. Yes. Thank you. So we need to copy this. We're gonna highlight.
Okay, highlight.
And you can either go to Edit and copy here, or you can right-click on here. You can go copy here, or shortcut keys are Control-C.
Mine's not copied.
It does copy.
It copies, but it remembers it. It's in the computer's memory now. And so if we make a new line by pressing Enter down here, we're going to be very careful. We put them in between the hamburger buns.
Whoa.
We're working with the meat and potatoes right now.
Mine is
So we need to paste it back in. And now we've got 4 lines. The first person who shows Mikey a heartbeat is going to be able to choose, who hasn't already gotten something, you're going to be able to choose a prize, okay? So that's Mikey right there. If you see something, or if you make a heartbeat, I want you to get Mikey's attention, and he'll come around and he'll check it out, and if it looks like a heartbeat to him, he'll ask you what you want, and then he'll grab it for you. So you're going to change those numbers so you're making a heartbeat. So think about a heartbeat. It goes. So like long, short. You got an error message. Cool. Okay. So we do got rid of the button that says
35.
So we're going to
35.
We're going to keep trying to do it until it comes back.
Where are you?
Yeah, what do you do long then?
No. So we got to see how we got it. And we want to go on 4 lines of code. Or sorry, 8 lines of code.
Yep.
That's what I did.
And Mike, let's do 2.
All we have are safety glasses left.
There's patches too.
And patches and
Stickers. So you need to make a new line.
I got a heartbeat.
Let's see what you got.
When you're running, you finish running.
Watch what you're doing. And how we're going until 11. How long?
She mentioned 11:30.
11:30?
And then lunch and a little recess break for them, and we'll be back in an hour, 12:30.
Great.
Will that work?
Yeah. I just wanted to, you gotta keep your eye on
Very
it.
close. You're right close.
Okay.
Very close.
Yeah, when you're running.
Good answer.
No, see, you're already figuring out your own error messages. Nice. So one thing I always say, really young kids, when they're there, cool, you got an error message, like positive reinforcement of error messages.
Yes.
Is the term error message. Yeah.
Yes.
What's the heartbeat?
Well, this is bad.
Yeah. Really small numbers. Really small numbers. Right?
So you have a short one and a long one. Short one.
Okay,
A lot of these are like, they're changing the.
So guys, we're gonna play around with the heartbeat for like another 3 minutes, okay? And if you already did the heartbeat and you wanna play around doing something else, you can copy and paste again, and you can make 3 different links.
Nice.
You can start doing like Morse code. Secret messages. Send secret messages to the world. Yeah.
yes. I got it. I got it over that right here yesterday.
Oh, nice. So look, we're tying it into history, guys.
I got it.
That's pretty amazing. Tying it into history in the technology classroom. It's pretty sweet, but you can do it.
I got it. What do I get?
You got it?
Two with one.
I like that.
2 minutes.
We're out.
Play around.
We have to beat to the punch next.
And very long.
Yeah.
Long. Short. Well, actually, it's long.
Yeah. So you've got them constant rate. If you look at hers changes.
7.67.
Okay, so we're up there. So we're going to change these numbers. And we're gonna play around with this for a little bit. You guys have these kits for the whole year. You guys have some knowledgeable people here to help you. So see how it goes off for longer? So try changing these all four of them all different. See what they do. Play around. Okay, guys, one more minute, and then we're gonna start plugging components in. We're gonna start plugging LEDs in. We're not gonna get to like motors and stuff, but Vaughn and Andy and Eric and Miss Lindley will be helping you guys with that in the future. Okay? Future.
I got 878.
Hey. Actually, I'll let Angela show now. And so some of you guys are making it go really fast. Some of you guys are making it go slow. So in between, yeah. Dinosaur heartbeat?
Yes.
Oh, because it's really slow? Yeah. Didn't some dinosaurs also have like a heart in the body and in the brain?
Yes, they did.
Yeah.
Yeah.
Because their bodies are so big.
Yeah, they needed two
Yes,
hearts.
yes, they did.
They had one heart,
So
especially
you're making it
blood in their
slow,
radio.
huh? You're already putting together other circuits. That's totally cool. As long as you're following the directions. Okay. As long as you're reading the instructions, that's totally cool. Like I said, guys, pay attention to me 75% of the time. If you want to push ahead and you want to look at the SIK guide, the little booklet, you're totally encouraged to do that. Because then you can share it with other people. It's also great for classroom management. Because you've always got something in your back pocket. You can say to the kids that are more advanced. Oh, okay, put together the next circuit. So I cover the basics. And leave the advanced circuits kind of as like a reward. It's really interesting. Like the harder stuff is a reward. You got one? Oh, nice. Nice. Perfect.
I just want
40?
I just want this one. Oh, this is good.
Right? Yeah.
I put it right where my O says.
Okay, guys. So next thing we're gonna do, you guys can come back to this later, okay? But I need you guys following along with me. We're gonna plug some LEDs into our microcontroller. So I want you guys to find an LED. That's a light emitting diode. It looks like it's gonna be in.
You have red and yellow.
Yeah, the red and yellow looks like this. I'm going to steal one from you, okay? And make sure you get it back at the end of the class. Okay?
Red and yellow, right? These suckers?
Yep. So yeah, it's a light emitting diode. Okay, guys? So this is a diode. A diode means it's a puzzle piece that can only go in one way. Okay? It has a positive and a negative.
I
Yeah?
know what way it's supposed to go in.
Do you know which way it's supposed to go in? Okay, which?
It's supposed to go in where the light is.
Where the light is?
Yeah. And it goes right here.
Yep, it goes into 13 and GND.
Yep, right there.
Yeah. So guys, the long one, if I can think for a really long time about one thing, that's positive, right? But if I can only think about something for a really short period of time,
That's negative.
that's negative. So if we look at these wires, one of them is long and one of them is short. If I'm long on patience with you as an instructor, That's a positive attribute. If I'm short with you, that's a negative attribute, right? Yeah. There's also a flat side of the LED. The flat side of the LED, if you guys look at the top, it's kind of hard to see. But the flat side looks like a negative symbol, okay? It's on the negative side. So we need to plug the negative side into ground, GND, and the positive side into the pin that we're blinking, pin 13. So it says number 13. And Mikey. And so when we plug it in, guys, yeah, you guys will know if you did it right. Like I did it wrong, okay? But he's got it right. I want you guys to hold up your LEDs once you've got them blinking. So the long one goes into 13. The short one goes into GND. Nice, nice. And so this is really cool for classroom management because I don't have to ask any questions. I just go around and look, and I say, okay, he's got his LED blinking, he doesn't need any help. If you can even set up a system where you tell people, if you've got a question, I want you to light up an LED. So you can actually say, if you've got a question, light up an LED, and you just watch the LEDs. We also have teachers who will hook up microphones for this. And once it gets too loud in their classroom, the frowny face will show up at the front. So you can use it for classroom management. You guys can create tools. You can have the students helping to create these tools for classroom management. I'm saying using a sound sensor. And once it gets to a certain threshold, you flash an LED or you have a frowny face up front. Or you can change the thresholds depending on speaking time or just lunch time. So we're giving constructivism back to the teachers as well as the students. You guys can make musical staircases in your school. And then you're probably going to wonder because you're getting more publicity. And the kids are going to want to come to school. You're making it part of their school culture. Right? You're giving them a stake in the culture and developing the technology. They want to show up the technology in math class because then they can make an interactive note. Or they can sew LEDs into the cake of their school mascot. Let me get you guys' attention. I really like it that you guys are excited. This is awesome, but I need your attention, okay? So let's talk about what's going on with the electricity. So, yeah.
I know what's happening.
Okay.
The light took place of the blinking light.
Yep.
So it depends how fast yours was or how slow it was.
Exactly. Yeah, guys. So our code is making this blink. So our code, when we talk to LED, it's sending electricity out through 13. The electricity is going through the LED and back down to ground because the electrons always need to flow. Okay, they always need to go from power to ground. So we're going to talk about the code next. But you guys understand what happens if I take the LED and I plug it in backwards?
It won't work.
It won't work, right? That's because it's a diode and it has something called polarity. Okay? It's a puzzle piece that only fits in one way. So you guys can experiment with this. For the adults in the room, there's a current limiting resistor in the microchip, and that's why we're not burning out the LED, because this provides 40 milliamps of current. So voltage is like how far the electricity can travel, and current is how much work it can do. But just like people, if we do too much work, we get really tired and we burn out. Just like components. If you try to put too much electricity through this LED, it's going to burn out. It's no good anymore. Okay? It's just like you guys, right? If you don't get recess and you do too much work, even if the work is fun, then you're going to get super tired, right? You're going to burn out. So we need to make sure we don't send too much electricity through this. But there's something called a current limiting resistor. There's a resistor in here so that we don't burn this out. And this is a 40 milliamp system, so you never have to worry about the kids hurting themselves. The worst thing they're going to get is a static shock. The worst thing it's going to do to your hardware, guys. You might short out if you're just like plugging stuff in randomly. You can damage this, so make sure you know what you're doing when you plug stuff in. But the worst thing you're going to do to your computer is short out your COM port fuses. And the way you fix that is you just restart your computer. So if your computer is ever not talking to this guy, just restart your computer, okay? This is designed as a teaching tool. You're going to have a hard time doing any damage to your computer. It's like almost, it's pretty much impossible. So let's talk about the code, guys, okay? Because there's always the circuit side and then the code side. So we talked about the circuit side. We talked about the LED. Yeah.
About the LED, the LED actually, if it has too high of a current, then it won't burn out. It just won't let any electricity flow through there.
No, it'll actually burn out. It'll go really bright, and then it'll stop working forever. That's because you destroyed it, yeah. So you got to be careful with that. It's like if we plugged it into 5 volts, we could burn it out. And that's actually an excellent teaching, like experiential learning. Talk about experiential learning. If you plug the LED into 5 volts and into ground and burn out the LED, those kids are never going to forget that. It's a great way, it's a really cheap way. If you bulk order LEDs, like I'll actually point you towards other websites where you can bulk order LEDs. If you bulk order LEDs, it's like a 1/10 of a cent for that particular lesson, and it's great for teaching all about current and current limiting resistors and how that stuff works. So guys, let's talk about the code, okay? We're going to talk about the code because we talked about the circuit. There's always 2 parts to physical computing. You guys are doing physical computing, okay? So let's talk about the code. In here, we've got gray code. Gray code are comments. They're intended for human beings, okay? Okay? And so what we're going to do is we're going to actually put a comment in here. And so, because comments are very important, when you work on this really hard, you want everybody to know about the projects that you worked really hard on, right? So we're going to put our name in here. So I want you guys to go down below where it says // make a new line, okay? And we're going to put a comment in here by making 2 slashes. You see how it turns gray? 1 slash is black, 2 is gray. So I want you guys to make a new line and make 2 slashes. And we're going to write our name in here. So I'm going to write my name because I want the world to know that I worked on this code. If you're having trouble making slashes,
you want to be right after. There you go. Perfect. 2 slashes and then we're good. Right.
and put your name in there. Doesn't matter.
If
it's not gray, guys, look what happens if I don't have my 2 slashes. It's not gray. That's how I know it's not a comment.
Oh, put a slash right there.
Right in front of your name.
If you guys don't put comments in your code, and one of your teachers comes around to try to help you, it's no fair to the teacher, okay? It's kind of like if your teacher just marks a problem wrong, and they don't write a comment about why it's wrong, it doesn't help you learn, does it? No. So we had one of my coworkers had a kid who wrote 5,000 lines of code for a really complicated robot. Okay? That robot was talking to satellites to get its position, just like you guys can learn how to do, like I was talking about GPS. Okay? But he didn't put any comments into the code. Even though he was really good at coding, he was really, really good at coding. But it came to game day, and he tried to upload the code, and there was one error. Okay? But there wasn't a single comment anywhere. So my friend took a look at his code, and he said, I can't help you, because there's no comments. So he had to walk away, even though this guy had put so much work into it, because there were no comments, there was no way to help him with his code. So you guys always have to put comments in that says, I'm trying to do this with my code, or I think this is supposed to turn on my LED, okay? Because what happens when I give Mikey my code for my breakfast making robot, okay? He might change it, right? And if he doesn't change the comments, let's say he changed the pancake making robot to a waffle making robot, right? Yeah, but I don't know. I don't know when I go back to look at the code, right? So it's really important that everybody put comments into their code. So did everybody put a comment in?
Yes.
You guys see how to do that with the 2 slashes? There's other ways to do that, and I'm sure you guys are going to explore that in the future. Let me show you really quick. If you highlight the text, you right-click, we can do comments or uncomment here. That's another way to make comments.
And then what do you do when you highlight it?
You can click on, like watch, if this isn't a comment, but I want to make it a comment, I can highlight it, and I can click on comments or uncomment. That will actually, bam, turn it into a comment.
So you turn it off of the comment.
And then I can turn it back into uncommented.
Comment.
Yep, there you go.
Pretty sweet, right? And I can put a comment next to my code. So see how this is real code, guys. This isn't gray. Yes.
Whoa.
Actually, if they were altering your code, they should have written a comment to say they were making a heartbeat code, right? And maybe how they did it.
Yeah. Yeah, exactly. So like, yeah, like Mrs. Lindley was saying, and this will be an important thing. Documentation is very important, guys, because then how does anybody know what your code is supposed to do if you don't document? It's just like scientists. That's the most important thing for scientists to do. You guys are now officially technologists. You were technologists before, because you guys get the opportunity to work with Scratch, which is awesome. And so now, one of the important things of technologists is documenting so that other people can use your stuff. That's the cool thing about open source, free information. It helps everybody. And it really helps your teachers and you learn. Okay? So let's talk about the rest of this code. This code right here, this is an integer variable. So you guys remember how I was talking about variables? Yeah. Variable, it's a container for what?
What kind of stuff?
What kind of stuff? Cheese?
Yes, cheese.
No, not cheese.
Information.
Information, yes. Okay, what kind of information is this? Oh, sorry. What kind of information is this? This guy right here.
13.
It's 13. It's a number. It's an integer because there's no decimal, okay? That's why it says INT here. And its name is LED. We could name this, we could totally name this like our school mascot is a bunny, okay? Or we could name it sour cream and onions is the best potato chip flavor, okay?
Yeah.
But would that make sense?
No. Yes.
No, that would not make sense. Because we're talking to an LED. So we want to name it something that makes sense and is short. Because imagine if every time you wanted to use this piece of information, you had to type sour cream and onions is the superior potato chip flavor, right? That's not convenient, is it?
But what if we already don't?
So your other one would be 11, right?
11,
And guys, for a challenge, if you did this and you're just hanging out, so you've got the LEDs blinking at different times. See if you can get the LEDs blinking together at the same time. You're going to have to add commands in. Talk to LED 2 and LED.
Yep, that one. It's just the short leg.
Or just play around and have fun. It's interesting. This is we sometimes do 8-hour classes with kids this age and younger. And then at the end of the day, they're like, do we really have to go? They've been doing math and computer science for 8 hours. As long as you give them some recess time in the middle, like they don't want to leave. It's insane.
They always ask, can I stay doing recess? We're doing something.
Yeah. They love this stuff. You can slip in algebra, Cartesian graphing, units of measurement.
Yeah, not me, Cartesian graphing. I could never slip that in.
No, video games. You have to. These guys are teaching Cartesian graphing in Scratch, I guarantee it. Because you have to know your XY coordinates in order to figure out how to get your people to go.
Are you having safety so your computer doesn't fall?
They know so much more than we do.
but they're a resource, right? It's all about community.
They teach us stuff all the time.
Tech.
And, you know, their video gaming, you know, people put that down, but their video gaming teaches them so much.
And if you can get them building video games.
We were actually talking about, I was at
LED stick. Yeah. Yeah, guys, we're gonna have some free time now, and you guys can play with doing different LEDs. And if you want, as long as you can plug in different LEDs. What's up, buddy?
I'm trying to make them blink at the same time.
Well, you solved the problem though. That's what engineering is all about.
So save as. Go ahead and save it as, and give it a name. You completed the challenge. Nice.
I completed the challenge.
GoPro doesn't work on the smartphone.
Wait,
They had it on a helmet. Yeah.
You would have to learn so much math. If you guys are into video games and you guys want to make your own video games, you have to pay attention in math class, guys. Algebra and calculus are really important for making video games. Sure. Yeah, lots of geometry.
And so it just like totally switched.
Hey,
They
good
have
code too.
awesome. They even